Alright, sorry about that.
Hello there, this is an Algebra 2 video. It is Chapter 8, Section 1, and today we're going to be learning about multiplying and dividing rational expressions. You might recall that when we talked about different types of numbers, rational numbers are basically fractional numbers, numbers that are a fraction. So when we say rational expressions, we're talking about polynomials, which you're very familiar with, but now you have expressions where there's a polynomial on top and on the bottom. So a lot of factoring going on in this lesson. You have to make sure that your factoring is up to par. And so we know that we can't divide by 0. So when it says over here, under what conditions is this expression undefined, it's basically asking you when will you have division by 0 as a problem, because we cannot divide by 0, so we need to basically exclude those values from our domain, so to speak. So the first thing we're going to do is kind of show you how you can multiply and divide with rational expressions, just like you would with normal fractions. But I already know that in general you tend to dislike fractions. So just try to be open-minded about this lesson and not assume automatically that it's going to be the worst thing that ever happened to you. Okay, so one of the first things you want to start off with, like I said earlier, is to factor as much as you can. Because most of the time, a lot of the factors are going to cancel from the top and the bottom. And so the first thing I want to do is take this x squared plus 4x plus 3, and I want to factor that. So I'm going to put x and x here. And then since 3 is a prime number, I'm going to have 1 and 3. And it turns out that I get 3x plus 1x, which is in fact 4x, which is the middle term. Therefore, my factors for x squared plus 4x plus 3 are going to be x plus 1 and x plus 3. So now this is gone, and I can replace it with x plus 1 and x plus 3. On the bottom, we have x squared minus 9, which you can also factor using this method, but you might also recognize it as x squared minus 3 squared, a difference of 2 squares. So we're going to go ahead and use our formula, and that's going to be x minus 3 and x plus 3. And then again, that's going to remove that factor from there. So now on the top we have 5x. So we have that factor, x plus 1, x plus 3. On the bottom we have x minus 6, x minus 3, and x plus 3. And generally, as I said earlier, you're going to have factors that are going to cancel. They're going to be common on both top and bottom. For example, the x plus 3 here cancels the x plus 3 at the bottom. The x plus 1 on top doesn't cancel with either of these, and the 5x doesn't cancel. So our simplified version would be the 5x and the x plus 1 on top. And on the bottom you would have the x minus 6 and the x minus 3, just like so. However, when it comes to determining when the expression is undefined, for that you actually have to go back to the original equation, and any number that causes the bottom of the original equation to be undefined or division by 0 is going to count. In other words, the x minus 6 is a problem, so x cannot equal 6. So 6 will make it undefined. And then because x squared minus 9 is x minus 3 and x plus 3, x can also not be positive or negative 3. Even though the x plus 3 cancel on the bottom, we still need to include the negative 3 as part of the numbers or the conditions that make it undefined. So x equals 6, negative 3 or 3 is when it's undefined. So now if you will try this little guy, remember again that the conditions where it's undefined has to be based on the original equation, not just on the results. This is your part B for the do-it-yourself, same instructions. And then we go to example 2, and it's asking us for what values is this expression undefined. And again, it doesn't really matter. We could simplify this expression. They never actually asked us to simplify the expression, but we could simplify the expression if we had the time. But we don't really need to, because in order for it to be undefined, all that matters is the bottom of the function or the expression. So we have a factor of 4x. And then we're going to go ahead and factor the x squared plus 6x plus 8. I'll do it over here. So we're going to go x and x. And then for 8, let's try 4 times 2. And that'll give us 2x plus 4x, which is in fact 6x. And that's the middle term. So that's the right combination. So then we're going to have an x plus 4 factor and an x plus 2 factor on the bottom instead of all this. So for what values is it undefined? A lot of times students will remember to do x equals -4 is a problem, and so is -2. And in case you're wondering where I'm getting those numbers from, it's because I'm taking each factor and making it equal to 0. So if x plus 2 equals 0, then I'll subtract 2 and it'll become -2. In this case, I'll subtract 4, it'll become -4. But the number that people forget about here is from this factor right there. And when you have a factor of x, whether it's a 4x, a 10x, a -3x, anytime there's an x factor out here, it means that you're going to have 0 as an option as well. Because if x is 0, then dividing by 0 times anything would be 0, and again, you'd have division by 0. So don't forget about your 0. So you actually have 3 values where the function would be undefined in this case. And here is your do-it-yourself question for example 2. And then we'll move on to example 3. And this time we're going to simplify. We're going to show you how sometimes you can factor out a negative to make things a little bit easier. But first, I'm going to show you, like before, we're going to want to factor. So I look at the top expression here, and I see that both terms have a w. So I'm going to factor out the w, and it's going to give me 4w minus 3y. And then I have w plus y. On the bottom, I have 3y minus 4w. There's nothing in common there. And then I have 5w plus y, sorry. Okay, and what you might notice at this point is that these two factors, the 4w minus 3y and the 3y minus 4w, look awfully similar. And I didn't think at the beginning to factor out a negative, but now that I'm looking at my result and I'm seeing that these are really close, they're just opposites. Instead of this being a positive 4w, I have a negative 4w, positive 3y, negative 3y. It doesn't really matter in which order they're placed, but they're just opposite signs. So you can change that really easy by making this negative. If I put a negative w instead of a positive w, now, and I don't want to do it there, I want to show you what I mean. Instead of taking out, for the beginning, instead of taking out a positive w, what if I take out a negative w? Then in that case, I would have, and I can also switch the order. If I put the 3y first, and then the 4w, see what happens is negative w times 3y is negative 3wy, which is what that is, negative 3wy. Negative w times negative 4w is positive 4w squared, which is that there. So not only did I factor out a negative, I also rearranged the order of the y and the w so that it can match the bottom one. And the reason why I wanted to match the bottom one is pretty obvious. I wanted to cancel. And you can't cancel it just because it looks the same. You have to make sure that you factor out that negative. So now that I've done that, the 3y minus 4w will cancel, and your final answer will be negative w times w plus y. And on the bottom, you'll have only the 5w plus y. Now, you might want to redistribute the negative w. I'm checking the book to see what they did here, and they did not redistribute the negative w. So that would be your final answer. So just another way of making sure that if you see factors like this where they're pretty much the exact same thing with opposite signs, then try factoring out a negative instead of the positive. All right, so now you can try that in these two, and then we'll move on to example 4. In example 4, we want to simplify expressions, but now we're actually multiplying and dividing two rational expressions. Thus far, you've only been dealing with one rational expression at a time. Now we're going to embark in the next couple of examples on what to do when you have two rational expressions. So we're going to start with some smaller ones, and then we're going to move on to some bigger ones. And one of the things that I want to remind you is that anything that's on top and on the bottom that has like terms, you can cancel from the get-go. It makes it a lot easier when you do that from the very beginning, so you're working with smaller numbers. For example, I know that 6 and 5 don't have anything in common, but 5 and 15 do, and 6 and 8 do. So I can take 2 goes into 6 3 times, and 2 goes into 8 4 times. I know that 5 goes into 5 once, and 5 goes into 15 3 times. And then this d can cancel one of these d's, leaving it instead of d squared would be due to the 1 power. And then there's no a's on top to cancel with this a, and there's no c's on the bottom to cancel with these c's. So now that I've done all the canceling that I can actually write out the expression. It'll be 3 times 3, which is 9, and then c times c, which is c squared, and then d to the 1 power. So 9c squared d. On the bottom I'll have 1 times 4 is 4, and then a. And that'll be my final answer for that guy. 9c squared divided by 4a. All right, and then part B, in this case we have division. And so when you have division, remember that the key to this problem and beyond is that when you have a division, it's easier for you to think of that as the multiplying the reciprocal. So that's the same thing. The definition of dividing is multiplying by the reciprocal. And that's what's going to help us out here. So I'm going to go ahead and rewrite the first portion, 18xy cubed divided by 7a squared b squared. And instead of a division symbol, I'm going to have a multiplication symbol. And then I'm going to reciprocate the second expression. Don't reciprocate both, and don't reciprocate the first. You always reciprocate the second. So 35a squared b on top, and then 12x squared y on the bottom. And now I can continue like I did in part A and see if there's anything in common. Again, nothing in common between 18 and 7, but we do have something in common between 18 and 12 and 7 and 35. So 7 goes into 7 once, 7 goes into 35 5 times. 3, I believe actually 6 goes into 18 3 times, and 3 goes into 12, 6 goes into 12 2 times. So we put 6 goes into 18 3 times, and 6 goes into 12 2 times. We also have a squared here and a squared there. We have an x here and an x squared here, so we'll make that just x to the 1 power. We have a y cubed here, which will be y squared because this is a y to the 1. And then we have a b that will cancel, make this a b instead of a b squared. So now that we've done all the canceling that we can, we're going to go 3 times 5 is 15. And then y squared. And then we have no a's, no b's. Okay, so on the bottom, we're going to have 1 times 2. And then you have a b and an x. So your final answer would be 15y squared over 2bx. That would be your final answer. Alrighty, so now you will try these two do-it-yourself questions, and then we will go on to example 5. So you can see that we're doing pretty much, oh, I'm so sorry, this is still part of the do-it-yourself. There's an A, B, and a C, D, and then we go on to example 5. And now what you can see is that our expressions have gotten a little more complex. The previous expressions were all just multiplication, division. Now you've got addition, subtraction going on. But again, the key is going to be for you to factor, factor, factor. Factoring is going to be your friend to the end. And that's not just meant to rhyme, it's totally true. So on the top, I want to factor out this expression up here. So I'm going to do x and x. And 16 could be 4 times 4, which is not going to give me a negative 6, but it can also be 8 times 2. I think I'll have more luck with the 8 and the 2 to get a 6. I want it to be a negative 6, so this is going to need to be a negative 8. And so I'm going to get negative 8x. And on this diagonal, I'm going to get positive 2x, which is going to equal negative 6x. And that's what my middle term is. So this is the right factorization. So I'm going to come over here, and we're going to have x minus 8 times x plus 2 on top. And then we're going to go ahead and factor the bottom part. So I'll do that down here. And again, we're going to have x and x. And for 64, we could do 8 times 8 is 64. But we need a negative 16, so I'm going to make both of these negative. So that negative 8 times negative 8 is still positive 64, but negative 8x and another negative 8x from both diagonals will actually give you a negative 16x, which is what we need for that middle term. So on the bottom, we'll notice that we have x minus 8 and x minus 8 are the same factor. So that means we're going to get x minus 8 squared. And then over here we have x minus 8. On the bottom, we're going to factor again one last time. X, we're going to do 2 and 3 this time to get 6. 3x plus 2x will give us the 5x that we need. And so on the bottom of this fraction, we'll have x plus 2 and x plus 3. So you can see already how important it is for you to be able to factor. Then we can see a lot of things that you can cancel from the get-go. We can take the x plus 2 out. This x minus 8 can cancel with one of these x minus 8s. And then this x minus 8 that's left will cancel with the x minus 8 on top. And so you have 2 x minus 8s on top, 2 on the bottom, so they've all canceled. Your x plus 2s have canceled. Excuse me. And then one mistake that I want you to try to avoid is that when everything cancels on the top, a lot of times students want to write the answer as x plus 3, but that is not the case. X plus 3 is on the bottom of the fraction, so there is still a top to the fraction, but when everything cancels, what you leave there is a 1. So the answer is actually 1 over x plus 3. Do not just write x plus 3. The answer is 1 over x plus 3 for part A. And then we're going to do one more. And again, can't stress enough how important it is for you to be able to factor, to make this a more simplified version for you. Pardon me as I blow my nose real quick. And so on the top of this expression, we're going to have, this one's an easy one to factor because it's a difference of 2 squares. So we're going to get x minus, sorry, not x minus 2, but x minus 4, because it's going to be x squared minus 4 squared. So x minus 4, x plus 4 for that guy. On the bottom, we have a binomial, so we don't have to use the other method for factoring trinomials, but they both have a 12 in common, so I'm going to factor out the 12, and that's going to give me y plus 3, because 12 times 3 is 36. So that's the first portion here, and if you remember, when you have division, you want to convert it to multiplication. So I'm actually going to take the y squared minus 3y minus 18 and put it on top, because I'm going to reciprocate. Before I do that, I want to factor them. So I'm going to go ahead and factor, we're going to get y and y to get y squared. And then for 18, we're going to go with 6 and 3. But I want a negative 3 here, so I'm going to make this a negative 6. So that I have 3y plus negative 6y, which is actually negative 3y. And that's what I want. So my factors for the y squared minus 3y minus 18 are y minus 6 and y plus 3. But instead of putting them on the bottom, because I'm going to reciprocate, remember, I'm going to put those factors on top. So we're going to have y minus 6 and y plus 3. Then on the bottom, we're going to factor the top portion of the original, which is x and x here. To get a 32, we can probably do something like 8 and 4. 8 times 4 is 32. And we want this to both be negative because we need a negative 12 and negative 8x and negative 4x. Sorry about that, my pen's delayed there, is going to give us a negative 12x, and then negative 8 times negative 4 is positive 32. So those are the right numbers. So again, remember that this is the x squared minus 12x plus 32 is going to be factored to x minus 8 and x minus 4. But again, although it's on the top here in the original, because we're reciprocating, this is actually going to be placed on the bottom of the fraction over here. So we're going to get x minus 8 and x minus 4. And then we can proceed as we have in the past by canceling anything that's in common. So we can take the x minus 4 from here and cancel the x minus 4 from there, the y plus 3 from here with the y plus 3 from there, and then of course everything else has to stay. This time on the top you're going to end up with x plus 4 and y minus 6. On the bottom you're going to have the 12, which is still there, and the x minus 8. And that would be your final answer, x plus 4 times y minus 6, excuse me, multiplied by 12 times x minus 8 on the bottom. And again, just in case you're wondering, it doesn't matter in which order you were to place those factors, as long as the right factors are on the top and the right factors are on the bottom. All right? So now you can try this is part A of do-it-yourself number 5. And then this would be part B of do-it-yourself number 5. And then we're going to go to our last example, which is example 6. And in example 6, we're going to show you how to deal with a complex fraction. And it's considered complex because it's a fraction within a fraction. But lo and behold, you've been doing that in the previous example as well. It just didn't look like this. They were using the other method of writing fractions, which is easier to look at. This looks ugly because you see too many fraction bars and it kind of confuses people. But you've done this in the previous ones where we have a plus b over 4, which is a fraction. And then instead of using the division bar, you could use the division symbol. And then you could have the second fraction, a squared plus b squared over 4. So it's really the same thing. And we've already learned how to deal with this. We basically reciprocate the second fraction. So that would then become a plus b over 4, waiting on my pen here, and then times the reciprocal, which would be 4 over a squared plus b squared. So in the future, you can actually just shortcut by going straight from this to this, converted from a fraction, a complex fraction, a fraction within a fraction, to actually simplifying like that. Once you do that, it's actually quite easy to simplify because the 4's are going to cancel. And so in the end, you're going to get a plus b over a squared plus b squared. And no, a squared plus b squared is not the same thing as a squared minus b squared. So you cannot, despite everything within you that's trying to tell you to cancel, you cannot cancel the a squareds and the a and the, now if that had been a squared minus b squared, then you could factor the bottom and then cancel the a plus b. But in this case, it does not factor. That is the final answer for part A. So we'll do that one more time. And this time we'll just skip ahead to the shortcut, which is basically to just rewrite it as a multiplication problem. So I'm going to get x squared over x squared minus y squared, and then times the reciprocal of the bottom. So I'm going to get y minus x over 4x. Just like that. Now if that's too confusing for you, you're always welcome to rewrite it with the division symbol and then go forth from there. But it's going to be x squared over x squared minus y squared times y minus x over 4x. And now it's just a regular problem we have in the past. You want to factor anywhere you can. And so at the bottom of this guy here, that's a difference of 2 squares. So it's going to be x minus y times x plus y. And then you can factor whatever you can. So you can see already that you can definitely factor out the x here with one of the x's up here. And then you're looking at this y minus x, and this looks strangely like y minus x as well, but it's not exactly the same because you see the y is positive, the y is negative, the x here is negative, the x here is positive. So basically it's the exact same thing with the opposite sign. So what you can do there is you can actually factor out the negative, so rewrite these to put the x's first, so it would be negative x and then plus y instead. And then you could actually factor out a negative. So we're combining a little bit of everything in here. If I factor out a negative, then this will be positive x, so that I will get negative times x is negative x. And then I need another negative here because negative times negative is positive y. So I'm using that whole method of factoring out a negative. So now the x minus y from here, so this is now gone, it was replaced by this, and this is replaced by that. So now what I'm looking at is x times negative x minus y over here, and then I still have a 4 on the bottom over here, and over here I have x minus y times x plus. I just want to rewrite it so that it looks a little bit cleaner for you. And now it's very plain to see that this x minus y will cancel with that x minus y, and then for my final answer I'll get negative 1 times x, which is negative x. On the bottom I'll have the 4 and the x plus y. And this will be my final answer for part B, negative x over 4 times x plus y. So now you will try this do-it-yourself question. This is part A, and this is part B. And once you have completed this do-it-yourself question, you will have completed your notes for this lesson. And I will see you in class, and thanks for watching.